Hello, everyone. In this video, we are going to look at example 4 in section 4.2 and section 4.3. So this problem puts in context some of the ideas we've been learning about in this chapter about areas under curves. So in this example, we are told that a barrel that starts out empty is being filled up with water. After t minutes, the rate at which water is being added to the barrel is given by R of t gallons per minute. So R of t is gallons per minute. The values for the function R of t are given in the table below and plotted to the right. So let's just take a moment to reflect on this table. So here we have minutes after we've started filling up a bucket. So 0, 2, 4, 6, 8, 10. And here we have the rate at which the bucket is being filled. So 5 gallons per minute at first, and then 3.39 gallons per minute, etc. So part A says, is the amount of water in the barrel increasing or decreasing? Explain. So because the rate at which water is being filled up is positive, that means the amount of water is increasing throughout. So I'm going to write that down. Since R of t is positive, meaning the change of water is positive, so meaning we get more and more water each minute. The amount of water is increasing. And maybe I'll even be more specific. The amount of water in the barrel. In the barrel is increasing. Now note, you might have thought that, well, these values are going down, so then we should have decreasing as the answer here. So notice we're not asked how is the rate changing or the amount of water being increased, how does that change? We're asked about the water itself. And because the rate at which the water is being filled is always positive, we're getting a positive number of gallons being added per minute each time. So that means as time moves on, the amount of water increases. Okay, so now let's look at part B. Part B says estimate the integral from 10 to 0 of R of t dt and include the correct units with your answer. Then give a complete sentence interpretation of your answer in the context of this problem. So let's recall how we were estimating integrals in the previous problems. To estimate, we were using left and right sum rectangles. So we can do that here. So using purple, we'll do the left rectangles. So it makes sense, since we're given a value every 2 minutes, to have rectangles of width 2. So I'm going to start drawing out my rectangles here. So using the left sum, we have 1, 2, 3, 4, 5 rectangles. So this will be left sum using 5. The heights are going to take place at these left-hand endpoints. And so now I just need to compute the area. So the area of these rectangles will be R of 0. The height occurs at 0, which is the left endpoint. So R of 0 times a width of 2 plus R of 2 times a width of 2 plus R of 4 times a width of 2 plus R of 6 times a width of 2. And our final rectangle, R of 8 and a width times of 2. All right, so now using either the graph or these tables of values, we see that this becomes 2, factoring that 2 out, times 5 plus 3.39 plus 2.09 plus 1.19 plus 0.65. So putting that all together, this becomes 24.64. So this is the area of left rectangles. And we're going to talk about units here in just a moment. But before we do that, let's look at the right sum rectangles. So we'll again use these 5 rectangles because that makes natural sense to break up the interval from 0 to 10. But now rather than look at the left endpoints, we're looking at the right endpoint. So our first rectangle will be here. Next rectangle over here. Third rectangle, fourth, and fifth. So now we can find the areas there. We're still going to have 2 is each width. So I'm just going to go ahead and factor 2 out. Then we're going to have r of 2. Here we start with the right endpoint. So the height we start with is r of 2 plus r of 4 plus r of 6 plus r of 8 plus r of 10. And then using the values of our function r, we see that this becomes 2 times 3.39 plus 2.09 plus 1.19 plus 0.65 plus 0.34. And we get, in the end, 15.32. This is the area using right rectangles. Okay. So now what would be the unit? So maybe I'll step back here. So these 2 estimates we just computed estimate, or what do these values estimate? Well, they estimate that integral. And to further estimate, what we can do is take an average of these 2 areas. So let's write that down first. So then the integral from 0 to 16 of r of t dt is about 24.64 plus 15.32 over 2. So it occurs somewhere, we don't know what the function does in between, but the area is going to be somewhere in between these 2 values. So we're going to add them up and divide by 2 to take an average. Okay, so let's focus on units. So important here. Correct units. So the area of these rectangles is computed by height times width. So what we've just computed is an area, which is width times height. So the width of these rectangles is time. So the units of our area is going to be time times the output units, which is gallons per time. I can do minutes here. So my time is in minutes. So I could just write that out more specific. Minutes times gallons per minute. And what happens here is that the minutes cancel out and we're just left with gallons. So what we're computing when we're computing this area is an accumulation of water in the bucket. So the units are gallons. So if we actually compute this average, we get equal to 19.98 gallons. So let's go ahead and write out a sentence then to make sense of what we just computed. So this indefinite integral means, so this value we found means after 16 minutes, or from 0 to 16, about 19.98 gallons have been added to the bucket or barrel, the vessel containing the water. Awesome. Great job, everyone. Quick update I just want to make in this video. So the 16, we saw 16 pop up. That was just runoff from the previous example. This integral should be here. I'm going to use a red so we can really see it, just 0 to 10. And then this means after 10 minutes, from 0 to 10 minutes, we have that almost 20 gallons have been added to the bucket. And then let's go ahead and just finish off this last note. So it says, note in general, the units of the integral from a to b of f of x are units of the function, so units of f of x, times units of the input x. And so we saw that in this example, it was minutes times gallons per minute. And that's why it's so cool when we take an integral of a rate of change that typically the rate units cancel and we just get the accumulated value. So that's why integrals are so cool. We go from a rate to an accumulation of a quantity. All right, so cool. Lots to think about, chew on, meditate. Thank you so much for your hard work, and we'll see you in the next video.